Hi everyone, how are you all? Okay, so let's see the solution of previous few questions, right? So let's see solution for this. So let's see this question first. What this question is saying that suppose the original linear regression gives you the weight of W star. Okay, this is the best weight or this is the optimal weight, which means that we are saying that whatever is the loss function, okay, let's suppose this is yi minus w wi xi something like this, right? Whole square. Okay, so whatever is the loss function, then at that point in time this wi, okay, the best wi, okay, is basically w star I, or in other words, if you like to write terms of in terms of basically vector, you can write w transpose x, but that's fine. So basically they are saying that this is w star, okay, that the best w that we were getting earlier, this is w star, right? Now they are saying that they have multiplied each input, okay, they have multiplied each input to c, which means now they have multiplied this xi to c, which means now it is cxi, right? So which now what we need to do in this w such that now also we get the best result, right? I mean, or the minimum loss. So basically it is as good as saying that we want earlier we wanted to minimize this loss, so it was wi minus yi minus wixi whole square divided by n or something like this, right? Something like this. So earlier this was the loss. Now uh, and it was the minimum loss at w star. At w star I was getting the minimum loss. Now what we are doing, we are basically making, instead of this xi, we are making it to be cxi, right? So now we want to minimize this loss. So what changes, or what are the things that w will be doing to accommodate this, right? So instead of xi, now I have cxi. Okay, now with the new input I have cxi. Now you tell me that if I want, see, I want this wi to be the best, right? Or let me write it w dash or something. Okay, so basically I want it to be the best. Now earlier this w star was giving the best result, which means it was minimizing the loss. Now, now, if I want to match with the earlier, then in that case, here I just need to do a little bit of adjustment. So in that case, I can say it will be W star, okay, whatever is earlier by C, such that the multiplication remains same. So C will get cancelled out, and W star Xi is basically anyway minimum, right? So what I'm trying to say is that, yeah, this is the question. The answer is A, that you will be getting W star divided by C, which means whatever is your previous, and your previous is basically W star. Okay, W star Xi was your previous. Now your new is, let's suppose, W dash, right? W dash, and then this is CXI. This is CXI. So from here you can find out that, okay, we want these to be same, right? Why? If the product is same, then we don't have to worry anything. Then the loss will be anyway minimum, because loss is nothing but, if you see the loss, then it is nothing but summation over yi minus wixi. Okay, if this product is same, right, then the loss will be anyway same, right? It will be the minimum loss, again it will be the minimum loss, right? So since it is linear regression, it is, the question is just trying to say that even if you do the linear changes to your input, okay, in that case there won't be any change to your final loss. So basically w will adjust itself. So in this case w is adjusting like this, okay? So w got adjusted like this. I hope that is fine to everyone. Understood? So W got adjusted like this. Okay. So which means A is the correct answer here. Okay. A is the correct answer. Now let's see this question. In this question, they are saying that they have defined a new loss. Okay, the loss, it is original loss. Now the new loss they have defined is basically log of the previous loss. Okay, now they are saying that log is strictly increasing function, which is statement is correct. The value of w that minimizes the both loss is same or not. Okay, so which means let's suppose earlier you are using L. Okay, or some let's suppose, let me write loss. Okay, this is your earlier loss, right? Mathematically it could be any expression, but this is your earlier, you were using it earlier. you are using this, right? Now, okay, let me write it maybe in the mathematical expression. Okay, y minus w transpose x. Let's suppose. Okay, or maybe write like, let me write like this, whole square, right? So some earlier loss was there. Now they are saying you take the log, okay, of this loss, and then you differentiate. I mean, see, if you want to find out the best w, what will you do, right? We will differentiate and we will find out the best w. This is the earlier setup, okay? So we will differentiate and will find out will find out the best w, right? So we will differentiate and then we will find out the best w. That's how we will do earlier. But now what they are saying, they are saying that you can do one thing. You can basically take the log, okay? So log of, so let me write now. Now we are doing, we are basically taking the log of whatever is the earlier loss, right? And we are calling it new loss, okay? And then we are differentiating. So basically now also we need to differentiate, okay? But after taking log, if we differentiate, then will my answer change? That is the only question that they are asking, okay? After taking log, if I differentiate, then will my answer change? For example, if earlier, if I'm asking that, okay, which value of x minimizes this expression, okay? For example, okay, which value of x minimizes this expression? Suppose if I ask you something like this, then you can differentiate, right? And you once you differentiate, you will be getting 2x minus 2x plus 3 equal to 0. Then you will be getting probably minus 3 by 2, right? X is minus 3 by 2, right? So this value of x is minimizing this function. Now, if I log it first, now let's suppose if I take the log, okay. Now if I ask you which value of x is minimizing log of this, okay, so log 3x, or sorry, I need to take the complete log actually, right? I cannot do like this, so need to take the complete log x square plus 3x minus 2, okay. Now if you differentiate, okay, you will be getting the same answer. Now if you differentiate with respect to x, then you will be getting the same answer. Or basically, I mean, if we want to see in the better way, then actually we use log, okay, many times we use log just to tell that, okay, the differentiation could be easy, okay. For example, if I want to find out the optimal value of x here, then first I need to multiply and then do the things, right? But instead of that, we can first take the log, okay. Then this is log x minus 2 plus log x plus 3, right? Now you can differentiate. So actually many times it happens that even in machine learning, I'm telling you that after taking log, differentiation becomes easy, okay. So log is basically the standard practice in machine learning questions. So basically log doesn't impact anything, in the sense that whatever x was minimizing this, okay, the same x will minimize this. I mean, the answer will not be same. I mean, the loss will not be same. Let's suppose this is 5, then this will be log 5. Okay. But x value, let's suppose 3 is minimizing this. Then x value 3 is also minimizing this. That's what I'm saying. Okay. I mean, the loss will not be same, but the x value will be same. Okay. So x, whatever, sorry, w value, whatever w earlier was minimizing, w was minimizing loss, same w will minimize log loss. Okay, same w will also minimize or maximize, right? Will also minimize log loss, which means what I'm trying to say here is that I'm just trying to say that log is increasing function basically. So if the earlier this was the ordering, let's suppose between two w's, okay, this was the ordering. Now also the ordering is same, okay. Now also the ordering is same. So basically, taking the log doesn't make the ordering different, right? If you multiply with a minus, then yes, the ordering will be different. Whatever was the earlier minimizing, now it will maximize. But taking log doesn't make any ordering difference. Okay, so basically you can say the argument means the value of w. Okay, argument means the value of w which is minimizing this loss. The same value of w will minimize the log loss, so that's why answer is a. Okay, the answer is a. Okay, now let's solve this question. This is question number 3. Let me know if you are liking the questions. This is question number 3. Consider the weighted linear regression loss. Okay. Now they are saying here they have put some weight here. I mean Ri is the importance of ith training example, which is okay. To find the optimal W, we differentiate WRSS. Okay, this is the loss function with respect to W. We want to differentiate this with respect to W. So what is the differentiation? That's what they're asking. Like how to find out the differentiation. So what is the answer? This is easy. Basically you need to differentiate with respect to w, right? So what we can do, we can just let you understand this on the next page. So here let me write it like this first. See, let me open it for you. Okay, this will be r1 wx1, right? Wx1 minus y1. Let me write x1 like this, wx1 minus y1 whole square, right? Plus r2 into wx2 minus y2 whole square, and dot 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 so on, right? If we differentiate with respect to w, then let's just see the first term. 2r1 2r1 wx1 minus y1, right? And then 2 will be here, and then we need to again differentiate with respect to w, this term. So which means you will be getting x1, right? 2r1 x1, right? Similarly here also you will be getting the same thing, 2r2 x2, right? wx2 minus y2, something like this you will be getting. So basically you can say don't worry about the summation. Okay, for now you don't worry about the summation. You can solve for the ith term and then you can put the summation again. So which means the pattern is same. So you can say it is 2 ri xi w xi minus yi. Okay, something like this. So let's just see what is the correct answer. 2 ri xi w xi minus yi. So b is the correct answer here. Okay, so B is the correct answer. Let's just see. Yes, B is the correct answer. It was easy question only, but yeah, B is the correct answer here, right? Okay. Now let's see this question. In this question, they are saying that this is a linear regression question only. They are saying that this is model 2 where they have simple linear regression, but here in the model 1 they're adding one more term, right? They're adding one more term. Now they're asking which model is better to fit. Okay, so in model 1, see, in model 1 what they are doing, they are basically having they're having bi cap equal to w square x plus wx, right? In model 2 they are having bi cap equal to wx. Understood? So these are the two models. Now see here that in model 1 what we are doing, if you take w common, then it will be x plus wx or wx plus x, something like this, right? Or you can take x common, so that you can see that what are the parameters here. So w square plus w you can say is a parameter, right? Now you can replace this w square plus w with some theta, so it could be theta x. Okay, so ultimately it is theta x. So basically ultimately you can say, if you take the x common, then it will be theta of x, right? You can write like this. Now the other one is wx, and now this is theta x. Do you think they will be same? Do you think they will be same? The interesting part here is that this theta could be refined. I mean, see, w can take any value, right? W can take any value, but can this theta also take any value? Can this w square plus w can take any value? Okay, so can now our question is that, see, this w can take any value, but can this theta or this w square plus w, okay, can take any value? Can w square plus w take any value? See, there is a method you might have seen in your childhood, which is called completing the square. So if w square plus w is there, then you can say the coefficient of w is one. Okay, so in case of like x square plus bx, okay, plus c also you can write. So basically, whatever is the coefficient of x, which is basically b, you add and subtract b by 2 whole square, which means b by 2 whole square. You add and you subtract b by 2 whole square. Okay, and then this thing, okay, this thing will be your x plus b. Let me just tell you. See, if it is x square plus bx, okay, let's suppose, let me only write this, then in this case, that case, what you can do, you can add and subtract, okay, you can add and subtract b by 2 whole square, right? Now this will be same as x plus b by 2 whole square, right? A square plus b square plus 2ab, right? And then minus b by 2 whole square, which is basically b square by 4. Okay, b square by 4. Basically, I mean, what I mean to say, you can rewrite this term like this, right? So similarly you can rewrite your w square plus w as w square plus w plus plus 1 by 4 minus 1 by 4. Okay, I mean, I'm adding and subtracting 1 by 4, then it will be w plus 1 by 2 whole square minus 1 by 4, right? Okay. I hope you understood. So basically, what I'm trying to say, that this w square plus w, I wanted to check whether it can take all the values or not. But now you see that if I ask you that what is the minimum value of w square plus w, you need to check the minimum value of this, which is 0. So you can say if this is theta, right? Then if this is theta, then theta equal to this. So theta will be at least greater than equal to minus 1 by 4. I mean, it cannot take any value, any real value, right? So earlier we were able to take any real value, but now we are not able to take any real value, right? So this w can take any value from minus infinity to plus infinity, right? This can take any value, but this w square plus w, or this theta, is not able to take any value. It is able to take maybe greater than minus 1 by 4 to infinity, something like this, right? I mean, it is not taking any value. So that is why it is less expressive. You can see model 1 is less expressive. So hence model 2 will fit the data better. Okay, see here, b is the correct answer, because if you write then now this model will look exactly same as model 2, but there is a catch. The catch here is that the w square plus w cannot take all the values. Okay, if we get some expression which can take all the values, then then it's not an issue. Okay, but currently it's an issue. Understood? Okay. Now let's just do this question. This is question number 5. Okay. This is also easy question. See, in one of the similar type of question. Okay, I have asked you to differentiate. Here I asked you to differentiate, but the differentiation was with respect to w actually. Okay, with respect to w. Okay. Now I'm asking you to differentiate in this question. I'm asking you to differentiate, but here the differentiation is basically, yeah. So here the differentiation is basically with respect to b. Okay. I'm taking wx plus b this time. So now you need to differentiate with respect to b. Okay. So let's just see how we can differentiate with respect to b. Yeah. So actually, for this question, in the lecture, I think I have said that both model will fit the data equally good. But I feel like I like then later I researched. So in the original, let me just tell you that in the original source, okay, they have given the answer as like both are fitting pretty. I mean, equally well. Okay. In the original source, they have given this answer, but then I thought about it. I researched about it, so I think that answer should be B. That model 2 will fit better. Okay, because A is less expressive. Okay, so we can correct this in the lecture also, because in the original source they have given C as an answer. I have not written the original source. That was there in the lecture, but here I have not written the original source. But yeah, the same question I think was in the original in the lectures also. There I have given C as answer because in the original source C was the answer, and it was standard university. But when I am redoing this question, I feel that A should be the answer. Okay. Sorry, B should be the answer. The model 2 will fit data better. B should be the answer. Now, let's just differentiate this with respect to B. Okay. If you differentiate, then don't worry about the summation or don't worry about the psi. You can just differentiate. Okay. This term. You can just differentiate this term and then we will put the summation later on. Okay. Let's just differentiate this term. So, differentiation of this term with respect to B will be what? It is basically 2 into W xi plus B minus Wi. Okay, this square is here, and then you need to differentiate with respect to B also, right? If you differentiate with respect to B, then in that case you will be basically saying that this is 0, this is anyway 1, right? So there is nothing more, you will be multiplying. So that's why what is the answer? You can put the summation here. Okay, 1 to n, I equal to 1 to n. So what is the answer? I think D is the correct answer. Okay, D is the correct answer here. Understood? Just a second. Yeah, for this question, D is the correct answer. Okay. So I hope you understood this. Now, basically, if you are confusing, if you are getting confused in this question number 4, then I feel B is the correct answer. Okay, although although in that resource C was given, but I feel B is the correct answer. Okay, because model 1 is somehow restricted. Okay, you cannot have all the possibilities in the model 1. That is the reason. Okay. So that's all. Like these are the 5 questions that I wanted to discuss. Now we will be having daily questions, as you know. So we will be solving daily few questions. For now, thank you everyone.